Hi everyone, this is Rashik from Rashik's Math Tutorials. This is my first video lesson and our topic for today is system of proportions. So let's get right into it. And if you're unaware of such a topic in mathematics, it's probably because I did not know what most people call it. So I decided to call it a system of proportions. And you'll understand why I decided to call it that. But it basically involves taking multiple direct and inverse proportions and linking them together to find one common variable. And if it sounds complicated, don't worry at all, I'm here to help. So, if you're still confused about what kind of questions we're going to be solving and learning about today, these kind of questions. If 8 cows could eat 4 fields worth of grass in 6 days, how long would it take 12 cows to eat 3 fields worth of grass? So here you can see we have multiple variables. We have cows, we have fields, we have days, and we have to find one particular variable where we're given everything else. We have to find the number of days it would take a certain number of cows to eat a certain number of fields. So our strategy for solving these kind of problems is we have to set up, like I said, a system of proportions. But the very important thing that has to be kept in mind when solving these kind of problems and when setting up the equations to solve these kind of problems is that the approach we take to solve these kind of problems will depend on what kind of proportions we want to set up. And there are two kinds of proportions. The first one, direct proportions. Direct proportions are where you have two variables which must maintain a common ratio, and that common ratio is a constant, so k here. And what that basically means is, and this is incredibly important, when one variable increases, the other variable must also increase by the same factor that the first variable increased by. And if one variable decreases by a factor, the other variable has to also decrease by the same factor. And I'll get to what I actually mean by that. Let's create a short table here. Let's say we have x, we have y. And let's say our initial values for x and y are 2 and 6. 2 and 6. So, let's see, the common ratio here, we can calculate that on the side. Pretty straightforward. 2 over 6 or 1 over 3. Now what this means is whatever I do to x and y, I have to maintain that ratio. So let's say I decide to increase x by a factor of 3 and I make it 6. Well, it's not enough to only increase x. If I want to maintain that common ratio of 1 over 3, I need to increase y by the same factor of 3. So I get 18. And the reason why is if I now divide 6 by 18, right, I'm going to get the same ratio that I got over here. 1 over 3, 1 over 3. And that constant is what defines a proportion, a direct proportion. So that's one. The other type of proportion is called an inverse proportion. And this has a very similar concept, but instead of a constant ratio, we have a constant product. So x and y are related by their constant product. And what that means for us is, if one variable increases, the other one has to go down, the other one has to decrease. So remember, when it came for direct proportions, both of them went up or down at the same time. But with inverse proportions, if one goes up, the other one has to go down. So let's see an example of that. Say again, we have our x and our y. And this time, let's give the same values to x and y, so you understand what I mean by an inverse proportion. So last time, with the direct proportion, we divided 2 by 6. However, this time, since it's inverse, we're going to find a product. So 2 times 6 is 12. and we need to maintain that common product whatever we do to x and y. So let's say we increase x, like last time, by a factor of 3. So we get 6. Well, this time, since it's an inverse proportion, we need to change y, but we don't increase it by a factor of 3. We decrease it, or we rather divide it by a factor of 3. So we make it 2. And if you can see where this is going, 6 times 2 is equal to 12. And it's again that common product, our constant that defines this inverse proportion. So that's a basic run through of direct and inverse proportions. For a direct proportion, x and y increase and decrease at the same time. Whereas with inverse proportions, if x increases, y decreases. If x decreases, y increases. They go in opposite directions. And what I want, a small piece of advice, when we're dealing with system of proportion equations, like we'll be dealing with now, it's not so important to understand like the theory behind why or setting up the equation, where's the constant and all that. What's important is understanding conceptually what is a direct proportion and what is an inverse proportion. And you'll understand why that's more important in a second. So let's try solving this problem now. 8 cows, 4 fields, 6 days, right? So the way I like to approach these kind of questions is I like to make a table of the information that I'm given. So let's write days over here. Let's write fields over here. And let's write cows over here. Okay. Now, let's start with the first row of information that we're given. We have 8 cows, right? 8 cows, 4 fields, so 4 fields, and 6 days. 6 days. So this is one row because they're all linked to each other. Now, the second row, we're going to start with x days because we are solving for x. How long would it take? Right? How long would it take? So we're solving for the number of days here. But we're given the number of cows. That's 12 cows here, as you can see, and 3 fields. 3 fields. So, what's our plan of attack to solving this problem here? What we want to do is we're going to try simplifying things a little bit. What we want to do is, remember I told you how proportions are defined by constants? Well, we want to create a few constants here. What we're going to do is we're going to assume that one of the variables where we have all the information, in our case fields and cows, we're going to assume each of them to be constants and define the other variable in a proportion with days, because days has the unknown. And if that's confusing, I'll show you what I mean. So let's assume that cows is a constant, right? So we have a fixed number of cows, hypothetically. Now, let's think. Let's say we have a fixed number of cows, and we let those cows graze for a certain number of days. Well, after grazing for a certain number of days, you're going to eat a certain number of fields. Now, let's say we increase the number of days that we allow them to graze for. Well, they're going to eat more fields, right? Now, here's where the concept of a direct proportion comes. As the number of days goes up, the number of fields goes up, right? That's what a direct proportion is. That's the concept of a direct proportion. So what we're going to do now is, and this is the interesting part, this is why you might want to pay attention now. What we're going to do now is, we're going to write a proportion like this. Okay, so x over 6 is going to equal 3 over 4. Now you may ask why I wrote it in this particular manner. Well, You see here, since days and fields are directly proportional to each other, assuming cows is constant, we want to write their corresponding terms in the same direction, basically. So you see here how x and 3 match up in the same row, and how 6 and 4 match up in the same row. Well, here we want to do the same thing. We want x and 3 to match up in the same row, and 6 and 4 to match up in the same row when we write our proportion, because it's direct. Right. Now let's do the opposite. Right? Let's do the opposite. Let's assume, okay, we're done with cows being constant. Let's assume that the number of fields that we have is constant. Right? Now we're going to define the proportion for days and cows. So now let's say the number of fields is constant. Let's say we have a small number of cows, maybe 5 cows, and we let them graze on the fixed number of fields that we have. Remember, it's a constant. Well, they're going to eat all the grass eventually in a certain amount of time. Now let's say we increase the number of cows that we have. Well, if we have more cows eating on the same field as before, they're going to take less time to eat all the grass this time. So you see, this is the concept of an inverse proportion, where as the number of cows goes up, the amount of time or the number of days goes down. And so now what we want to do here is, in this, since the last proportion was a direct proportion, we matched up the x with the 3 and the 6 with the 4 while writing it, our notation like that. What we want to do this time is we want to match up the x with the 8 and the 6 with the 12. So you see here we wrote x by 6, right? So we basically wrote it in this direction. Well, we want to write this one in this direction. Okay, so times times 8 over 12. Now, I hope you're gaining a picture of what we're doing over here. We assumed one variable to be constant, and we set up a proportion between the other two, and then we did the opposite. Now, all we have to do is solve this equation. So, this should be pretty straightforward, right? 1 cancels out with 12 because 3 goes into 12 4 times. 8 cancels out with 4 because 4 goes into 8 2 times. Then 2 cancels out with 4 again because 2 goes into 4 1 time. So we can rewrite all this as x over 6 equal to 1 over 2 cross multiply 2x equal to 6. And there we go. X is equal to 3, which means, if we go back to our original question, it would take 3 days. 3 days for 12 cows to eat 3 fields worth of grass. I hope you enjoyed this lesson on a system of proportions with a small, brief review of direct and inverse proportions. Please subscribe to my channel. Please share this video with as many people as you can. Let's get those views and subscriber count up. See you next time. Thank you for watching.